Welcome to Summarize Science, where we break down the latest research. Today, we're looking deep into the heart of a stellar explosion, a supernova named SN 2024G. When a massive star dies, it goes out with a bang, scattering the elements it forged throughout the cosmos. These explosions are cosmic factories, creating the raw materials for future stars and planets. But how exactly does this process unfold? To find out, astronomers pointed the powerful James Webb Space Telescope at the ghost of this dead star. JWST can see an infrared light, which allows it to peer through the chaos and detect the chemical fingerprints of molecules forming in the debris. Here on page 4, you can see the light from the supernova's expanding cloud, captured about 285 and 385 days after the explosion. These peaks and valleys are signals from different elements, but scientists were most interested in these broad features here, which are the unmistakable signature of carbon monoxide, or CO. CO is a crucial first step towards making cosmic dust, the building block of planets. The researchers also noticed that the shapes of these chemical fingerprints were lopsided. This is a telltale sign that the original star didn't explode in a perfect sphere, but rather in a messy, asymmetrical blast. To understand this complex environment, the team developed a sophisticated new 3D model to decode the JWST data. This allowed them to essentially reconstruct what's happening inside the supernova's expanding shell. Their model revealed a surprising story. Most of the carbon monoxide wasn't forming during the observations, it had already formed earlier. In fact, the supernova was now destroying its own CO, as intense radiation from the core blasted the outer layers. They also discovered that the CO gas wasn't smooth, but was gathered into dense clumps. Over the 100 days between observations, these clumps became smaller, rounder, and even denser. Imagine the expanding cloud not as a smooth fog, but as a lumpy cosmic stew. So, let's recap the incredible details these scientists uncovered. The supernova explosion was lopsided and chaotic. The gas inside is clumpy and is evolving over time, with newly formed molecules being destroyed by the explosion's own afterglow. This is so important because it gives us a direct view into the workings of a cosmic factory. By watching how these clumps behave and how CO gives way to other molecules, scientists can finally start to understand the very first steps of dust creation. This process, happening in the debris of a dead star, is what eventually leads to the formation of new worlds. This study showcases a powerful new way to use JWST to turn a single point of light in the sky into a dynamic 3D laboratory. Thanks for watching Summarize Science.